All right, so we have some practice problems to help us use proportions to find the scale of something or to apply to scale drawings. So the first problem says, using the scale provided, measure the actual distance between Hagerstown and Annapolis if they are 4 centimeters apart on the map. So here is the scale on the map. 1 centimeter equals 24 miles. And so we want to use that to see, okay, if these two towns are actually 4 centimeters apart, how much would that be in miles? All right, so I'm going to set up my proportion using a word ratio first. I'm just going to use centimeters and miles, and you can abbreviate that. So I know from the scale that the first ratio is 1 centimeter to 24 miles. So I'm going to fill in my first set of boxes. And then I know that they are 4 centimeters apart, so I'm going to put that on top with the centimeters, and then this is what I'm solving for, so I'm going to call that x. And to solve, I multiply diagonally, or I use that baseball bat, so 24 times 4 is 16, carry your 1, 4 times 2 is 8, plus 1 is 9. So this is 96 equal to 1 times x, and so normally I would divide by that 1, but really 96 divided by 1 is just 96. I'm going to say x is equal to 96, and it is in miles. So those two towns are 96 miles apart. All right, on the second problem, it says determine the length of the model given the scale provided. So again, here's my scale. 1 inch equals 8 feet. So I'm going to use that for my word ratio, and then I'm going to set up my boxes. I know that 1 inch is 8 feet, and I can see from the drawing that the model is 60 feet, or the actual, I guess that's a train, is 60 feet, so that's going to go on bottom with my feet, x goes on top. So I'm going to multiply diagonally. 1 times 60 is 60, and I know that is equal to 8 times x. Alright, so this time I can't just divide it in my head. I'm going to divide 8 into 60, it will go 7 times 8 is 56. I'm going to subtract, I get 4. I'm going to go ahead and add a decimal and a 0 and keep going. 8 will go into 45 times. Right, so I know then that my model is 7.5 and it's in inches. So it's 7.5 inches long. Right, in the third problem, a model of a skyscraper is made using a scale of 3 inches to 76 feet. What is the height of the actual building if the height of the model is 18 inches? Alright, so just to be different, I'm going to use these words instead, actual and maybe model here. So I'm going to do the actual to the model. You can set it up using inches and feet if that's easier. Okay, so the actual would have been in feet, and the model is going to be in inches. Alright, so I know that the height of the actual building and the height of the model is 18, and I know that the scale is 3 to 76. So the model would be 3, and then the actual height would be 76. Right, and then I want to know the actual height when the model is 18. So that's going to go here on bottom with model. And actual is what I'm looking for. So to figure this out, I multiply diagonally first. 76 times 18. 8 times 6 is 48. Carry your 4. 8 times 7 is 56. Plus 4 is 60. Start a second row with 0. 1 times 6 is 6. 1 times 7. Alright, so I know that 1,368 has to be equal to 3 times something. So I don't know what that something is. So I have to work backwards, and instead of multiplying, I have to divide. You're going to 13 4 times. I subtract, I get 1, bring down your 6. 3 going to 16 5 times. I subtract, I get 1, bring down the 8. 3 going to 18 6 times. Alright, so that tells me that x is equal to 456, and this is the actual height, so that's going to be in feet. Alright, problem 4 says, on a map, the distance from Falls City, Texas to Pleasant, Texas measures 2 centimeters. What's the actual distance if the scale of the map shows that 1 centimeter is equal to 30 kilometers? All right, so if I go back to centimeters and kilometers, I know that 1 centimeter is equal to 30. So that's my first ratio. I want to know the distance. If the map shows 2 centimeters, that's on top with centimeters. And multiply again diagonally. 30 times 2 is 60. That's equal to 1 times x. So normally I would divide at this point, but I know that 60 divided by 1 is just 60. So x is equal to 60, and this is going to be in kilometers. So those towns are actually 60 kilometers. In the last problem, Corey is drawing a housing plan for his architecture class. He's making a scale model of one of the bedrooms. If the scale is 3 inches, represents 1 foot, what is the area of the actual room? All right, so I know that area is length times width, but before I find the area, I need to go ahead and change these into feet, because right now they're in inches. So basically, I'm going to have to do both of these, so I'm going to use 2 different proportions for that. I know that it's going to be feet and inches. Again, it really doesn't matter what goes on top and what goes on bottom as long as you keep everything else in the same place. So 3 inches, that's for me on bottom, 1 foot is on top. I want to know what 15 inches is in feet. What's on bottom? And then this is what I'm looking for. So 1 times 15 is 15. That's equal to 3 times x. So if I divide 15 by 3, I'm going to get 5. So x is going to equal 5 feet. I know that this is also 5 feet in the actual plan. All right, and then I'm going to do the same thing for 27. So feet over inches again, using the same scale as before. So 1 foot is 3 inches. And then now I'm using 27 inches. That's on bottom. I'm going to use a different letter since it's a different side. And multiply diagonally. That would be 27 equal to 3 times y. So I'm going to divide 3 into 27. That'll go 9 times. So I know that y is equal to 9. So really what I'm saying is that the length of the house is 9 feet. All right, and then I'm going to use this formula. The area of a rectangle is found by multiplying the length times the width. So now that I know the actual length and width, I can multiply these two. So 5 times 9. It's going to give me 45, and then area is measured in square feet, so I can write that with an exponent, or I can write it out as 45 square feet. All right, thank you.